Good morning. I'm very pleased to introduce Dr. Panayotis, or better known as Takis, Karkanas, a distinguished geoarchaeologist, for the first HEAS Archaeological Science Seminar of this term. The HEAS Research Network is today kindly hosted by the Austrian Academy of Sciences, the Austrian Archaeological Institute. We all made it here. It's the first time in this building. First, I was wandering in the fourth floor. Dr. Karkanas serves as the director of the Malcolm H. Wiener Laboratory for Archaeological Sciences at the American School of Classic Studies in Athens. He was born in Athens, Greece, and pursued his undergraduate and doctorate degree in geology at the University of Athens, completing the PhD in '94. Takis is celebrated for his meticulous research on site formation processes using a variety of geoscientific tools, including archaeological sediment micromorphology, and his work extensively covers paleo-environmental reconstruction and paleoclimate studies, which contribute significantly to our understanding of Old World prehistoric archaeology, notably the Pleistocene archaeology of Greece. With over 2 decades of experience, Takis has served as a senior geologist in the effort of paleoanthropology, speleology in the Antiquities Service of Greece, showcasing his profound expertise in both geology and archaeology. He is also a member of the American Academy of Arts and Sciences and recipient of the RIP Archaeological Geology Award of the Geological Society of America, underscoring his remarkable contributions to the field of geoarchaeology. In his seminal works, Takis often explores both the theoretical and practical aspects of depositional processes within archaeological sites, aiding in the systematic understanding of the geoarchaeological matrix, and that is pivotal for reconstructing archaeological sites. Together with Paul Goldberg, he has published the textbook Reconstructing Archaeological Sites, Understanding the Geoarchaeological Matrix. His breadth of knowledge, extensive field experience, not only in Europe but as well in Africa, and significant contributions to geoarchaeology make Dr. Karkanas a much valued member of our community and an inspiring speaker for today's seminar on archaeological soil and sediment micromorphology as a tool for revealing activities, practices, and behaviors. Takis, the floor is yours.
Thank you very much. And I would like particularly to thank Tom for the invitation to give this lecture here today and show you what micromorphology and geoarchaeology in general can do. So, why? Okay, so I will start first by presenting you some principles, probably propositions upon which I think, which me and Paul, geoarchaeological and micromorphological studies should be based on. Of course, most of you, I think all of you, you are familiar with this, but it's better, let's say, to repeat them. So whatever people leave behind in an archaeological site through their activities is reflected in the way a site is built and structured. And a site is not the three-dimensional, it's not the three-dimensional arrangement of artifacts, but it's the three-dimensional arrangement of artifact-bearing deposits, which means actually the focus, the elemental, let's say, unit of our study should be always the deposit, because this is the matrices that holds the artifacts. The artifacts themselves do not say the whole story. And therefore, you know, since the stratum is a body of sediment that is definitely the product of natural process and anthropogenic activities, the result, the build-up of the way the strata are built, produces stratigraphy. And the stratigraphy is the history of the site. So it's wrong, let's say, to say that the stratigraphy of a site is bad or is not preserved or it is reworked, because the stratigraphy is the history of the site. Whatever is disturbed or not, this is the site stratigraphy. So the important thing that actually our whole, let's say, way of interpreting micromorphology and geoarchaeology of a site is that the fabrics of the sediment are indicative of the different processes involved in their formation. And this is because human, as we move around in the site, in the landscape, through the actions of our forces, produce a unique three-dimensional arrangement of the particles of the sediment. So this is important, and actually this gives us the opportunity to study the archaeological remains in the same way that we study natural processes, because they are not much different, the human activities and natural processes, because they can be described both by because the elemental dynamics that describe, let's say, the transportation and the deposition of materials, which through actions, the everyday actions of the people are the same. They can be described the same because all these actions, as you see, the elemental actions of troubling, digging, dabbing, kneading, tagging, sweeping, brushing, discarding, and placing, produce all these produce fabrics in the same way that natural sediments produce fabrics. Now, I have realized that people do not understand what exactly we see under the microscope. It's difficult to describe it, but I assure you that the same empirical links that someone uses to infer that an arrangement of stone on the surface is actually a raw stone wall, it's the same link that we are using to describe and interpret a particular arrangement of particles under the microscope, that this is either a constructed surface or is a damp field or whatever. It's actually because everything around us is patterned. The way that the chairs are arranged here, it's a pattern that suggests that this is a room for giving lectures. The same thing actually you see under the microscope, arrangement of particles, and they tell us how actually the sediment has been produced, how have been brought in on the site, how have been formed. So together with the content, the fabric tell us about the processes that have made the sediments. And we use, of course, in relation to other fabrics of the surrounding sediments, the geometry of the bodies, the geometry of the contacts to infer and interpret further the archaeological remains. And I will show you here that micromorphology is the perfect tool for revealing activities, practice, and behavior. But before, very briefly, I will present you, I guess you are familiar, most of you, with the micromorphological technique. So what we are doing is we carve blocks of sediment in the profile of an excavation, for example. We sometimes plaster it with plaster of Paris in order to secure safe removal. We resin impregnate it, and then we cut them with rock sauce and produce these nice polished slabs. We photograph them at high resolution, and then we produce thin sections over here, which again are photographed at high resolution. So up to now, I think I can easily, let's say, probably describe to you what I see. For example, yeah, the stratigraphy that we can see the stratigraphy if I explain to you what I see. But when we are talking about what we move to photomicrographs that are produced with a microscope, I'm sure that you will not understand what I'm going to describe, because you have to be trained. The physics of the light is totally different, because exactly observation under a microscope relies in the change of the characteristics of the light. So that's why even if I show you something and try to describe you will not understand what I will say. You will probably think that this is a Jackson Pollock picture. And now I'm going to present you a case study that I believe that will show you how micromorphology can reveal behaviors in early human history. This is already published. This is a case of Pinnacle Point 56 site in South Africa, which is located in the coast of South Africa, southern coast of South Africa. You see an impressive landscape with sea cliff here, several caves formed along fault zones like here and here by former high stands, sea high stands. You see that actually it's not a cave, it's a rock shelter that has a slick cut configuration. You can see it here. It's blocked now by a remnant of a huge climbing dune that is colonized by plants. The stratigraphy, the site has a 40-meter long stratigraphy, very busy. You see here the plan view. We are going to concentrate, so I'm going to talk about only of the North PP5-6 site. You see here the blue line is the drip line, actually has been moved through time. It originally was somewhere here, then it moved towards this direction. This is based on observation that of the sediment, of the type of sediments that we see. And actually, the drip line separates the interior from the outside of the cave. And this, because the outer part of the cave is directly affected by the elements, while inside things are different. So I'm going to first describe you what I see under the microscope in order, let's say, to separate, to define the main depositional processes. So with this tool, then we go back to the stratigraphy and try to interpret how this was produced. So the first natural sediment, type of natural sediment that we see is dominated by roof spall, as they call it. So it's breakdown material from the roof and the walls of the cave. The cave is formed inside quartzite. So as it breaks down, produces elongated quartzite particles like this one over there. You see it. And when we have just free fall, you know, as it breaks down, the fragments fall, just they produce this chaotic arrangement of all lithic particles being in different directions, some vertical, and this black area here is the void. So it's a loose material produced by free fall from the breakdown of the roof. Now, sometimes we see this kind of features where the voids here are totally filled with this brownish material, which is fine clay. And you see now that the arrangement of the clasts follow this kind of structure, like a flow, like a wave, let's say, which actually is interpreted as sheet wash, the production of sheet wash, you know, gentle flow of water along the surface of the cave and moving the sediment downwards. And we have also some other interesting features like this down here. You can see actually that the particles are arranged in a certain way, like this here. So they show some kind of deformation, like folding, and this is produced by the sediment moved down the slope by gravity, mostly, mainly. Of course, also with the help also for some lubrication of the sediment by water. So these are called debris flow processes or gravity flow processes. Moving now to the next major type of natural sediments, we have aeolian sands. So this is how a pristine, aeolian sand looks like. This all these grains are rounded quartz clasts. You see that they are perfectly sorted. There are some lamina occasionally, and it's full of these darker particles that actually are bioclasts. So rounded shell fragments. This is a typical appearance of an aeolian sand. Now, when this sand, this let's say original type of aeolian sediment stays for a long time on the surface, all the dark clusters we can see here have disappeared because they have been dissolved. They have been decalcified, as we say, due to the water that percolates and dissolves the fragile calcareous clast of the shell. At the same time, they are enriched in this, as you can see here, brownish to reddish fine-grained sediment, which is clay. And this actually tells us that this is a reworked, decalcified sediment that has been stayed for a long time on the surface and it has been altered. Occasionally, when we have long stasis, so the material stays for a long time on the surface, we have the production of this red sediment, which are characterized by clay coatings. All these are coatings of fine clay around the clast. This tells us that this has been produced by percolating of very fine-grained material down the sand grains and coated them, implying that we have an exposure and a long, stable period where soils are formed. Now, moving to the anthropogenic deposit, first we have a major, let's say, type of sediment in Pinnacle Boy 5-6, of course, is are combustion features. We have two main types of combustion features: the in situ one, in situ intact combustion features. As you can see here, this is intact, an example of intact loose ashes, where we see half-charred material here that still preserves the original plant structure. And this is an indication that has not been moved or it's totally undisturbed, because immediately the slightest movement of the sediment will have destroyed the structures. At the same time, we see this exfoliated due to heating shell that stay together and they had not pulled apart and dispersed because exactly the sediment has stayed intact in the place that has been produced. Another type of combustion feature is this mixture, let's say, of ash remains, here you see, with sand grains, aeolian sand grains. So this is full of, the matrix is ashy, but it has also burned remains, like here, some shell, or here in the thin section, you can see it. It's full of silkite, heated shell, heated bone, and occasionally some remnants of in situ ashes, but the whole appearance, a massive mixed material of ashes and aeolian sand. This suggests that the ashes have been displaced, and probably because they have been at the same time quite becoming denser, compacted, and all the elements are horizontally aligned. So probably this means that probably the whole thing has been trampled as well. We also have some other type of, let's say, disturbed ash remains. This bedded, laminated sediment with alternating layers of pure sand and layers mixed with ashes. So these are interpreted as sheetwash, in this case of the human remains. Now, if we, now with this major type of sedimentation, we now move to interpret the stratigraphy and the way the site has been built. First of all, we have the lower part of the sequence, which is about 5 meters, and we call it the cliff because originally it was eroded and produced a natural cliff, but we have, of course, excavate the cliff towards the interior, and we have revealed this nice stratigraphy. First of all, what we see here is the central column, which is cemented, and this is actually the former drip line. The water as were moving downwards, I was dripping along the edges of the roof of the cave, the edge of the roof of the cave, produced a cementation, and you can see clearly that the outer part here is dipping towards the coast and does not have any anthropogenic remains, whereas the interior is horizontally bedded and is characterized by this generally yellowish sediment, which is actually roof spall, free fall or slightly removed by sheet wash or creeping and gravity flow processes. And this is, and in this, let's say, sequence of the 5 meters, we can see dispersed, equally almost dispersed, inside these half remains. If we, and you can see here in this detailed picture, how many actually this can be described as single, let's say, isolated, mostly intact half remains. We can count hundreds on the profile of the 5 meters, and we can have exposed, of course, as we later excavate them, even more. So they are characterized by this reddish heated substrate and a couple of centimeters of ashes and charred black remains. Even in the case that sometimes we see something that looks more thicker, looks thicker and more compact, having more, let's say, fireplace one above the other. Actually, laterally, you can see clearly they are separated by the roof spall, layers. So we do know from our reconstructions of the sea level in the area that at that time, which was the time, let's say, of the formation of the lower sequence, was between 90 and 75,000 years before present, that the site was very close to the coastline, only 1 or 2 kilometers away. The coastline was found, and therefore we interpret the huge amounts of roof breakdown, the production of roof spall that is produced due to spalling of the quartzite bedrock that was enhanced by sea salt that it produced because it was invaded, let's say, the pores of the bedrock and pull apart and break the quartzite. And we have seen actually the accumulation rate of roof spall that hardly crudely is related to the distance of the site from the sea. So what we have in this roof spall dominated sediment, we have numerous isolated combustion episodes, and because they are spread almost equally in the sites of the natural sediment, they appear like random and the result of opportunistic choice of where to make fires, because very rarely we find fires on top of the other, and still they are separated by roof spall. So this implies that we have a high geogenic input rate, but at the same time a low tumbling rate, because people, if there were a lot of people at the same time inside the cave, they will probably, and stayed for a long time, they have probably removed, destroyed, homogenized the sediment, and not leaving behind, let's say, perfectly preserved half remains. So we believe that the lower sequence is a result of small group occupation and short-term visits. Now, moving to the higher parts of the cave, we observe that there is a huge hiatus here that separates the lower sequence from the upper sequence. This is actually demarcated by these huge blocks of roof spall, and at the same time, a very strong lithified surface. Above this, let's say, hiatus here, the sedimentation totally changes. Natural sediments are not anymore dominated by roof spall, but are dominated by aeolian sand. And at the same time, inside the aeolian sand, we have thick sequences of ash remains. We can see here, this is a palimpsest of ashes, quite, let's say, layered, bedded, and their thickness is about, in this case, for example, in this unit, 70 to 80 centimeters thick, just pure ashes. But as I told you before, actually, these are a sequence of trampled earth remains or in situ displaced ash remains, with occasionally some in situ ash remnants of in situ ash layers. So in this case, we do know that this happens at around 74,000 years before present, that the coastline was 10 kilometers away at least. So the shelf was exposed, so there was material that the wind could remove and produce the aeolian dunes. First, then anthropogenic activities are characterized by flattening raking out and trampling that produce these thick sequences of slightly, let's say, disturbed combustion layers. And of course, in order to produce this thick sequence of ashes, implies that the people were making fires on the same area. This suggests fast anthropogenic input rate and high traveling rate at the same time. The natural rate of production the rate of production of natural sediments at the same time is high, but punctuated in the sense that we have occasional dune incursions and formation, and then for some time there was no aeolian activity, and the human remains, the combustion features developed. So this type, let's say, of anthropogenic activity is interpreted as intensive occupation, but of course still short and discontinuous occupation. Now, if we want to summarize what we see based on field appearance, field interpretation of the stratigraphy, and micromorphological analysis of the sediment, we have a lower sequence that is dominated by roof spore formation, then a major environmental change that leads to aeolian-dominated sequence. And this is actually at the same time followed by different human activities and behavior. First of all, in the lower sequence, we see single hearth remains that probably represent small groups and short visits, followed by periods of non-occupation. We have intensive exploitation of the tidal, intertidal zone with a lot of shellfish. All these single fire events are full of burned shell remains. And we know that actually from the zooarchaeological analysis that the plains above the cave was exploited for large mammals. On the other hand, immediately after we have this major environmental change, we have probably larger groups and longer visits in order to have this huge palimpsest of ash remains, exploitation of the wide coastal plain in front of the cave this time, and occasionally, of course, use of the intertidal zone. So because we still, let's say, see some shell exploitation, but it's the first time that we see a very intensive use of heat-treated silkcrete as a raw material. And at the same time, it's the first time that we have microlithic stone production. So this environmental change somehow is not exactly correlated, but led to a different behavior, human behavior, and human activities. So far, I described, let's say, the sequence from a long-term perspective, like long durée, sometimes we say. But I would like now to concentrate on some snapshots of activities. So the short-term behavior activities of the people. This is an ongoing study, so all these are preliminary results and need more confirmation. Yeah, okay, let's now going back to the lower sequence and focus and describe in more details the processes there. So in the lower sequence, as I have said, we see clearly tripartite hearth structured hearth remains with the roof spall, the reddened roof spall, the black chart remains, and the white ash remains. So you can see here nicely in this slab how these are clearly separate and appear and are discrete. Each one make a separate unit. Sometimes you have thick ash remains, like here, of about 1 to 2 centimeters. Sometimes the ashes are not so well preserved, but still you can see here and there small pieces of ash remains. So this is, let's say, the typical single fire event, or the so-called single fire event. Even if we have complex sequence like here, through micromorphological analysis, you can clearly see that all these are separated by roof spall formation. So there is no doubt that all these are isolated single fire events, and they all have the same more or less thickness, 1 to 2, 3 maximum centimeter thick in the center, of course, of the hearth. So the problem is what exactly a single fire represents. Is it one burning or are more burnings? Already, for example, this is just a detail of a slab. You can see that these 2-3 centimeters thick ash remain can be clearly separated by this line here to 2 discrete events. And actually, you can see here at the base of this boundary here, we have a roof spall. Just a few pieces that clearly says that we have at least 2 events here. We can also use, but yeah, sorry. Now in this thicker, let's say, ash remain, actually we can see that above, let's say, above the heated substrate, the ashes are actually characterized by tens of lamina. You can see here there are a lot of actually one above the other. Or let's say, if you cannot see clearly the lamina, you can see it more in detail in this thin section. Here is the lamina here, but under the microscope they are clearly separated. So it means that probably here we have several relighting events. We can also use the distribution of the burned bone and also the way that have been heated to probably separate firing events. For example, we can see here that they have 2 actually combustion features, one above the other. This one with the chart remains here, the ash is here, and then another one, the chart remains here, the ash is above here, and you can see that the bone here, this bone which is on the top of the previous combustion feature, has been heated more intensively at the very, very bottom of the other one. The same happens here, which is probably more easy to see, that this bone here on the top is more heated just at the bottom of the next fireplace, which means that these bones were already on the surface, and then they will be heated from the next fire event. The same we can say probably with the distribution of heated and unheated cell. Already we can see here that we have probably 3 or even 4 layers, 1, 2, 3, 4 here. And every time we see actually at the base of this ash increment here, exfoliated heated shell remains, whereas above, immediately above, we have fragments of not heated cell. And this is actually, you can see in the second one with this heated, unheated cell here, and this is an unheated cell. in addition to probably using the heated and unheated shell distribution to find how many times this hearth was relighted, probably we can also infer about cooking activities. For example, of course, this needs more work in order to let's say, to confirm it. But I believe from the first evidence that probably they were heated the shell inside the fire. So the first part at the beginning, let's say, we have exfoliation of some part of the shell. This stays inside the ash as they have been, they remove it. And then after consumption, they throw the whole shell above when the fire has been ceased. I'm going now to further exploit and try to interpret this single fire or these tablets of combustion fixtures based on my study that was published quite recently of 8-year experimental work with hundreds of open wood fires and laboratory experiments. What I have seen is that actually what I saw with this huge experimental work is that the thickness of the ash that is produced by a single fire event is not so thick as someone will think. For example, with 5 kilograms, you have just 3-4 centimeters of thick ash is produced. Then this is 6 kilograms, this is 7 kilograms, and this is 30 kilograms. So even if you, let's say, add a lot of fuel, you don't necessarily increase substantially the thickness of the ash remains of a single firing event. And the reason is that you cannot structure the fuel like a tower. The more fuel that you put on a fire, actually it spreads. And actually at the end, if you use a lot of fuel, you actually have, let's say, a larger fireplace and not a thicker sediment. At the same time, I realized that we all have seen it, but it's one thing to see it and then another to actually think what is the meaning and how you can use it in archaeology. That the ashes that are produced from a single fire event are very porous, light, fluffy, and easily removed with just a slight move of the wind. And not only this, I found that the slightest compression, because probably of overlying sediment or because of human traffic, reduces the thickness of the ash remains to about 90%. Just, the density, I actually try to estimate the density of the ash remains, pristine ash remains. It's extremely low. It's lower than 0.02 grams per cubic centimeter, which is probably one of the lightest, if not the lightest natural material on Earth. So this has a meaning, has a consequence, because it means that, first of all, a single fire event is very highly unlikely to be preserved in the archaeological record, only if it is buried immediately or if it is wetted. It can be stabilized and stay there. And when we find a fireplace, a remain of a single fire in the archaeological record, that's inside a sequence, sedimentary sequence, probably will have a thickness of a few millimeters. It's impossible to produce, to my opinion, a single fire event and produce in the archaeological record an ash thickness of 1 or 2 or 3 centimeters. And how this probably has been produced? I have found that when you relight the fire in the same place, you make fires one above the other, the ashes actually are cindered and produced, this cinder produces crusted ashes. So these are making more durable and can be preserved, first of all, in the archaeological record. And at the same time, the compression is smaller, it's about 40%, which implies that the sequence, let's say, of, and I will show you here, for example, in this diagram over there, you can see that after 40 almost relightings, the thickness is about 88 centimeters. After 20 or 25 relating events on the same in the same area to have the formation of 7-centimeter thick ashes. So what this experiment showed to me is that the increase of ash thickness in relief fires is not proportional. So the more fires that you put on in the same area does not mean that the ash actually that is the ash at the end that will be produced it doubles every firing event. I found actually because of this cinder self-compression of the ashes that the ashes after let's say their thickness doubles after about 15 relighting in the same place, 10 to 15 times relighting events. And this is actually how they appear, this ash remains after 40 relighting events. You have this fine layer appearance, and they probably each layer represents 5 to 7 fires, and under the microscope they appear like they appear as alternating layers of dense ash remains and more porous, which are ash remains that represent the crusted appearance in the field. And actually, we see this in PP56 cave. We see here the ashes that actually we have layers of dense ashes, this one, and this one, and then they are separated by looser crusted ash remains. So single, it's not a single, it means several firing events in the same area. And I made a calculation, of course it's a bit coarse and I cannot confirm it, based on the assumption that what I see in the cliff area probably can be continued in the whole unexcavated area. And if you make these calculations, then you find out that actually you have about 10,000 single fireplaces, and divided by time, it probably represents one single fire structure every year, and this suggests a seasonal visit of the site by these early humans. Now, how we interpreted then the upper sequence, the sequence that is full of raked out ashes and produce these thick palimpsests. Again, based on my experiment, I saw that actually the temperature that is recorded on the substrate, this is the temperature here. This is actually the time that this gap here, this curve here, this depression actually reflects the point where the fire has ceased. We don't see any flame, we don't see any glow at all. But as you can see, actually, the temperature continues to be stable on the substrate for hours. And actually, you can predict the temperature because, for example, between fire 5 and fire 15, the temperature stays inside a small area. So between, let's say, 400 and 300 in this case. And not only this, but I realized that when the substrate of the fires are actually previously deposited ashes, that this plateau here can stay for even 4 or 6 hours. So we have a predictable temperature on the substrate of fireplaces. And this is probably because of the high thermal capacity of ashes that sustain this high temperature for a long time after fire ceases. And therefore, one could suggest that this type of palimpsests can be probably related to some cooking or heating of chert, of lithics activity. And actually, it has been shown that in order to produce heat-treated silkcrete and other type of siliceous lithics, you need temperature between 300 and 450, but more importantly, that this has been this temperature has to stay stable for a long time. And given the fact that in Pinnacle 0.56 we see a lot of silkcrete, heated silkcrete in this particular sequence, it's reasonable to assume, or at least there is a good indication that needs, of course, more study in order to confirm it, that perhaps these palimpsests were the product of heated silkcrete activities, of course, in addition of the use of the fire for other uses as well. So I just want to finish here with saying that I hope I have shown you that sedimentary processes are important to interpret correctly the archaeology of the site, and the activities of the people, and the production of a stratigraphy through these activities actually shows us how the site has been built up, or the opposite. Actually, the stratigraphy reflects how the site, reflects the type of the activities of the people. And I hope I showed you also that the micromorphology can decipher behavioral changes and even sometimes reveal particular events in the biography of the site. And I would like just to thank, of course, the team that works in Pinnacle 0.56, in particular Professor Curtis Marian, who is the director of the excavation, and the rest of the people that helped me to make this work happen. Thank you.